Hello ladies and gentlemen, Jesse Warden here. Today we're going to talk about the OOP basics. So this is the small part of it. We have a lot to cover in a variety of different videos. So I'm just going to cover the beginnings. This is all you need to know. So who am I? My name is Jesse Warden. I work for Web App Solution, where I'm a software consultant and we help large companies do enterprise software. I like the client side, so I can do Python and Ruby. I think it's cool, but 99% of my work the past 13 years has been on the front end. So that's where I'm coming from an OOP perspective, okay? Being at one with the GUI. And I've been doing JavaScript in some form since 2001. So I have some form of background in ECMA, seen it come into fashion, out of fashion, back into fashion. So we're gonna cover object-oriented, also known sometimes as orientated, by those who can't speak English very well. Object-oriented programming. We're gonna cover the basics of it, okay? Just the things that you need to know from a classes or template perspective. I'm gonna cover the instances, what the difference is between instances and classes. A little bit about static, as well as the inheritance versus composition, okay? The two ways of really utilizing object-oriented programming, okay? And why? Why would I do this? What point does OOP have again from a programming perspective? I mean, it's not JavaScript specific, okay? This is programming in general. It's to learn the lingo, the nomenclature, you know, the OOP, do you speak it? When you're talking to other developers, whether they're just starting out or they're experts from a long time, you need to be able to speak their language. And object-oriented programming, or OOP, has a lot of concepts that fall under the umbrella term that allows you to effectively communicate with them. So it's just learning the lingo, man. Code organization. OOP promotes dry coding. Don't repeat yourself. Encapsulation, keeping things nice and tight, very specific at what they do, not, you know, tied strongly together like spaghetti code, right? So code organization. And scalability. If you have multiple developers on the same code base, dealing with multiple files, right? It allows your code to scale as it gets larger and larger for multiple people, as well as the code size, okay? And also, like I just said, behavior encapsulation. You want to encapsulate or protect, make very specific that behavior and expose that functionality that you need from it in a very specific way, right? To keep it encapsulated. You don't want to tie things together. You want to keep them nice and cleanly separated. So how do we do this? Well, we're going to do it via JavaScript, and JavaScript is unique in that it's one of the only languages next to Lua that doesn't really have a built-in class mechanism, doesn't have a built-in module mechanism, doesn't really even have an easy built-in inheritance mechanism. And yet, because of what people are doing with it nowadays, they need OOP. They need to build inheritance, composition, class structures, modules, right? To get all that, you have to understand the basics. And JavaScript provides basically 4 ways of doing that, not including the variety of libraries that try to abstract that problem away from you. So we're going to use JavaScript to learn, which makes it a little more difficult, but it's important that you see how OOP is approached from JavaScript. And then later on in future courses, I'll show you what the ideal is and where JavaScript's somewhat heading, okay? So we're going to talk about objects. We've already talked about objects in a previous video where I showed how you can build some forms of, you know, objects, and you're programming around those objects. We're going to expound on that example now. Building a set of classes. Now, we're not going to do classes in the traditional sense using the class keyword, right, that's offered in ECMA 6, a future version of JavaScript, or other libraries. We're going to build our own classes because there's a variety of different ways to do them in JavaScript. There's no clearly defined way. And keep in mind, most of these concepts have computer science definitions, right? I'm not going to get specific because most of those definitions aren't helpful. If you're a computer scientist, you're probably not doing this kind of stuff anyway. You're more interested in getting things done, okay? We're going to talk about instances, making a unique instance or implementation of that class or that blueprint, okay? So we're going to go back to our Gladiator example. We're just going to have our index.html open up in our Chrome here. And we're going to make our normal Gladiator. If you remember, he has a name, he has an age, he has an attack, which is 10. He has a defense, which is 12, and hit points, which are 10. And that is our object. Now again, as you can see, printing out in JavaScript, it's an object with all these attributes, right? So most objects in JavaScript are made up of 2 things. They have attributes, whichever data type it is, a string, a number, a date, an array, whatever, and behavior. The behavior is usually expressed in functions. So for example, we can add our say name behavior, which is a function. And we're going to say console.log, hello, my name is this.name. And he'll print that out to the console. So we'll refresh, say Jesse. And as you can see, our object now has normal attributes, just like other objects do. and behavior, a function. So we can say Jesse.sayName. Now you can do, I did something new today. I did something called this. It's a special keyword. As you can see, it's not highlighted in my code editor. Most code editors do highlight it. This is a very special keyword. It's called a reserved keyword. It's something in JavaScript that you can't really modify. So what that means is that we can't, change around the meaning of this or modify how it works. It's a word that has to be there. Most JavaScript uglifiers, which takes JavaScript and make it small and really teensy weensy for the web so it can download really fast, can't modify it either. But this has something very, very specific. We used it briefly in the past. This refers to this. It refers to the object that the function is attached to, or called from, or defined with, okay? Anytime this is broken is an immediate sign that you're doing oop wrong, right? Or that you may be thinking, something that's not wired up correctly. So this is a great indicator to determine if you're on the right track. So as long as this is working and working the way you think it is, then your oop structure is good to go, okay? So this refers to Jesse. Now I can also do Jesse, right? Refresh and say, hey, Jesse, say name. And internally I'll say Jesse.name, right? Prints the same thing. But again, objects as opposed to normal data types, a list of variables, right, are one variable that has many different values internally. So I can have one variable that represents this very complex thing, right? So rather than just a string or just a number, right, I can have an object that represents this thing with many different attributes on it that can also change. They retain their own state. Because of that, we tend to make many of them. So let's make another gladiator, and I'll show you why this is very important for even something as simple as objects. Make another gladiator called John. His attack is 12. He's a bit stronger. His defense is 10. And his hit points are 12. And we will copy pasta the function. Now, I always make fun of copy pasta coding, but it's been working in all my examples. Here's the first time it's not going to work. So I paste it in. Hopefully you can see the first problem. I have Jesse. Thus, that function is not as portable. It's not encapsulated. It has the dependency on another variable. It's hard-coded to that particular variable's name, right? Not very flexible. Oops about, supposedly, flexibility, right? It's not flexible anymore. So when I run John, he's an object. He's got a name of John. Cool. When I say John, say your name. His name is Jesse. That's wrong. It's because he's pointing to this. So let's fix it to this so it can be nice and encapsulated and portable. We'll refresh the page. Say Jesse and John. Both have their respective names on the objects. Fantastic. Jesse, say name. And John, say name. Cool. So we've learned just the simple ability of how OOP, or object-oriented programming, encourages encapsulation. And the way they do that is using the this keyword, okay? So using this, regardless of where the function is defined, it can work with that particular object and refer to that particular object. Make sense? So this.name, this.attack, this.defense, this.hit points, right? Any property on there or attribute, whatever you want to call it, is on there and can be accessible via this, as long as that function's attached to that object. You got it? The point of OOP in classes or templates is that you're going to create many, many, many instances. Now, right now, we've created many instances or variables of a gladiator object. Now, there's nothing that says gladiator. You and I just know that we're making objects that kind of mold or meld or are defined about a gladiator, right? A gladiator has a name, it has some attack and defense properties and hit points, as well as certain methods that allow it to do things. In this case, say their name. But we're repeating ourselves. And one of the rules in object-oriented programming in general, is dry. It's capital D, capital R, capital Y. That means don't repeat yourself. There's a variety of reasons why you don't repeat yourself. The ones that really matter are A, you can't change behavior of any one thing or all gladiators without changing all gladiators. If you have a template and you define that template in one place, when you change it, all gladiators are changed. So as you're building things, modifying things, fixing bugs, you fix it in one place, it fixes everything. If you start to repeat yourself, a lot of those bugs can sometimes be only fixed in one place. Sometimes you forget to fix it over there, right? So dry has so many positive connotations. In the case of object-oriented programming, dry allows you to define this template or blueprint of what a gladiator is in a single place. So we're going to use something called the factory pattern. It's a design pattern. It's just another nomenclature or lingo word saying something. When I say the factory pattern, you know what I'm talking about. And that is, I give it something and it gives me something out, right? That's a factory pattern. So we're going to say a factory function of make gladiator. We're going to give it a name, attack, defense, and hit points. And it's going to return our class template. So we'll take our existing template, which is good, and return it. Okay, this is good stuff. Let's format it just a tad here so it's somewhat readable. JavaScript readable. That's a good one, Mr. Warden. And we'll make everything dynamic. So the name you pass in will be set to the name. The attack you pass in will be set to the name. The defense you pass in, and so on and so forth. Notice we don't have to change say name because this, again, it's copy pasta coding. That works because of an encapsulated way of writing it using this. Good stuff, right? So we're going to get rid of these guys. We've now defined it in one place, and we'll go Jesse is a gladiator. Jesse, his attack is 10. His defense is 12. His hit points are 10. And John, make gladiator. John, capital J, 12, 10, 12. Refresh the page. Jesse and John are now basically the same exact thing as before. They both have their say name function. And John's say name. Whoops, try again, Mr. Warden. And as you can see, they say it works, it's good to go, but we've defined that template or class in a very specific spot. Now again, this is not really a class in a specific sense because we're actually creating a unique object instance, setting its properties and returning it, right? So in effect, it's kind of acting like a template. We've defined it in one place. We've created two instances or unique identifiers of that particular class. They are creations. That is how a class template works, but it's not really a template. Each one of these properties is unique for each and every instance. So as you can see, Jesse has a unique name and so does John. They both have the name property, but the value is unique for that particular object, right? So that is the basics right there. You're creating a class template and you're instantiating instances. Now, there's another way to do this that allows something that's a little more efficient. Premature optimization is the root of all evil, okay? But in our cases, it's good to learn how it works. So in RAM, each one of these objects has a unique address for that particular value and name, right? So this template is very expensive in terms of RAM. If you were to create many, many different instances, it's the same thing as creating many, many different objects, right? Not very optimized. So how can we prevent that from happening? There's another way to make a class. What we'll do is go up here and we're going to use something called the prototype. The prototype allows you to put things on it, and anytime you put something on it, anytime you say, all right, I want a new instance, it'll actually point to the prototype. So they all, if you have whether 1 or 500 different instances, they all point to the same exact property, except if you change it. This is where it gets tricky. Most programming languages have a class template you can't mess with. It's defined when you are coding. As soon as you compile or run your code, you don't modify the blueprint. Like you don't take a piece of blueprint paper and modify it while you're doing the building. But JavaScript is crazy and allows you to do that, right? Other languages like Lua and Ruby and Python kind of do that too. So it's not that unique. So we're going to make our class. The way you make a prototypal class is you start with a constructor function. So it looks like a function, but there's a key difference. The letter G in Gladiator is capitalized. This is a convention. It has nothing to do with JavaScript. It is merely just a convention that most languages do, except for C# or VB, to uppercase the letter to indicate it's a class, right? So if it's lowercase, it would be some kind of function that does something, right? But if you uppercase it, it's known to be a constructor function. Means it's the function that runs while the object instance is being created, okay? So every time you create a new object instance, it's gonna run. So we're gonna do the same exact thing we did with our make gladiator, passing in the properties. And we're gonna use the this function, right? Say, set my property to what you just said, my instance property. We're gonna do name, attack, defense, and hit points. Again, this refers to the object or the new gladiator thing you're creating, right? These refer to the parameters that you passed in, okay? So you're setting the internal values that are being created out to the defaults of whatever you pass into the constructor function. We can create those gladiators, but we're missing the key functionality, and that is the function. So we're going to comment out our existing way. Notice our APIs make gladiator. We're going to keep that the same. But the factory function is going to change its internals of how it makes things. So the people using the factory don't really care. All they know is they're getting a gladiator instance. Sounds good. But the factory is upgrading itself. It's going to make a brand new, more efficient gladiator instance. It's going to make sure that those properties or functions are more efficiently utilized, okay? So version 2 of the factory is going to do this. It's going to get an instance via new gladiator. Passing in name, attack, defense, and hit points, which are from this function right here. Make sense? Now, it looks kind of weird that you're newing a function. Well, welcome to JavaScript and any other functional language that allows you to do functions as objects. That's how you do it. You then return the instance, okay? So we can run it, test out Jesse, and test out John. Again, same thing. They both have unique attributes, right, as an object. It's just like a normal object has unique, they all have the same attributes, but the values of those are different. They're unique to that particular instance. The Jesse has a name of Jesse, the John has a name of John, right? Makes sense? Different values for attack. But there's one thing that you'll notice. They're called a gladiator. Chrome is smart enough to know that you're doing a higher level of OOP, a more advanced class templating system using the standard object.prototype, as it's called, right? And so it says gladiator. Okay, but you're missing the say name. Let's add it right now. Gladiator.prototype. That means anything I put on the prototype, well, every instance that's created will get a copy of that, okay? So we'll say name, and we'll copy the internals like before. Again, it's this, which means it's what? Portable. I can copy paste and it'll work for the most part. Okay, let's refresh, do it again. And as you can see, they now have their say name function, right? Now the difference between this and doing it this way is that 2 of these, using the object way, will exist in RAM. Not very efficient. This, only 1 exists in RAM. So if you have 1 instance, or you have, like we have 2, if you have 2,000, they all point to the exact same function. But why not the properties? Well, that gets very confusing. So real quick, let's just show you that the prototype works the same as you've been used to, as you've seen, right? My name is Jesse and John. This works just the same, whether it's on prototype or not. Exact same functionality. This refers to that thing, okay? So far so good. We got our constructor function and we put a method on prototype. Again, the only difference, this little guy right here is very helpful for RAM, okay? Cool, makes sense, feels good. You know, OOP is not that hard, right? You're getting it. This is just the second way of doing it. But here's the kicker. Why don't I put a property on there, okay? Let's add a new property. Let's say weapon. In this case, sword. So every gladiator who walks into the thing will default to a sword, okay? So let's refresh it. Let's say Jesse walks into the thing, walks into the arena. Ugh. So Jesse and John both have that. Notice their weapon property is not shown in the instance. And the reason for that is that it's assumed that if you don't set your own unique value, it's going to point to that prototype. Really frustrating and confusing, right? This is why Jesse Warden and TypeScript do not compile down to prototype classes and put properties on prototypes. They only put functions or methods because of this exact ridiculous behavior. Now, if you're a JavaScript aficionado, I'm glad you like it, but it's confusing. Most people learning program don't get it. People who come from traditional programming backgrounds don't get it, and it's not really helpful. So that's why we don't do it. So if you want to look, Jesse.sword, weapon. It is a sword. And again, if you open it up, you can't really see that property in there, but it's in there, okay? If you open the proto, you can see it. We'll get to proto in a bit. Look at John. What is his weapon? They both have sword, right? Because they inherited that particular property from that base template class, okay? So every instance I make is going to have a weapon that defaults to sword. Now watch this. Let's say Jesse weapon equals knives, dual knives, because Jesse's a thief. So Jesse.weapon is dual knives, and John.weapon is sword. Okay, so far so good. They all default to pointing to the same property value in RAM, so it's more efficient from an instance perspective. Makes sense. But Jesse still has the option to set his weapon to something else, and John could too if he'd like. Now, here's where things get nuts, and most programming languages don't do this, well, except for Ruby and Python, kind of. We'll go gladiator, prototype, weapon equals a cow. Okay. So, just to make sure we set it correctly, that's what the prototype property of weapon says. Now watch this. So Jesse's weapon is still dual knives. John's should be sword, right? Because that's what it was when we created it. Wrong, it's cow. So this is a kind of the polymorphism weirdness of JavaScript. You can change the class template at runtime while your program is running. And as long as no instances have changed their internal properties, they'll get those new updated values as well. So as long as they don't set it to their own value, it'll point to the prototype in RAM. Now, from a function perspective, like say name, that makes sense because most people aren't going to change the functions at runtime. You could, but most people don't. They get it. They have a roll dice function, an attack, a defense, and they just invoke those functions and call it a day. They're not going to overwrite them. Properties, though, are a little different. Most people, you would assume, would want to have unique values of it, right? So this exact reason is why most people don't actually use properties on the prototype, and programming languages like TypeScript and others, and then they compile down, they only put functions on the prototype. They don't put properties on the prototype, okay? Because of this weird behavior that's just not really helpful. It makes sense. It's it's like, if why not have the same instance until they actually need it? So that makes sense from a pragmatic programming perspective, in RAM and stuff. But it's so confusing, it doesn't really help, and most instances are expected to have their own value anyway, right? So that's why we don't. So again, weapon I take off, and again, instead I would put weapon in here. Just that weapon defaults to sword. Same thing, but now it's explicitly instance-based. So when you say Jesse and John, you can see the weapon is clearly defined there. It's clearly unique, and it's theirs, and there's no weird, property. Now, real quick, those of you from other programming languages may say, well, isn't that kind of like static? Where like every single instance gets the same property? Well, yes, but there's a better way to do static in JavaScript, and that is like this. So, for example, if you want to say how many instances do we have, or how many class instances from this particular class have been created, we'll put it on the class itself, not on the prototype. Because again, classes, functions are basically just objects, which can have properties and functions added to them, right? So it's a very loose, flexible language. So we'll say 0, and every time we create an instance, we'll increment it by 1. So that way, when we refresh and say Jesse and John, you don't see the property there, right? And you don't even see it in the proto, which we'll get to. Sorry, I know I keep saying that. But when we query the static property on the class itself, instances, you can see 2, Jesse and John. Every time we created one, we incremented the value. So that is a more appropriate way to do static. It makes sense. It's very easy to set. It's very clear as to where the value is actually existing versus this prototype, proto, constructor, nebulous sea of weirdness, right, that everyone does differently. So that is a way you can do static, okay? It's very difficult for us to do static in the normal object way because there's no real class. And the class template is also the object that you get. So you can't really do static that way, right? Or at least prototype, you have the option of doing that. So you can have these properties, you can have the prototype, which is efficient name, and everything else. Now there's one other benefit to prototype that I haven't talked about, and that is reflection, or identifying what type something is. Now we only have one class here, but watch this. You can see it's the type gladiator. There's something more to that. Watch this. We'll have cow equals new array. So notice I didn't say cow equals array, right? Object literal. I said new array. It's just an empty array, okay? We'll say cow instance of boolean. The boolean class. Is it true or false? No, false. It's not. It's an array. Cow instance of array. True, right? We know it's of type array. We can query what type of class it is, so you can do some high-level programming. Same with gladiator. Let's say, for example, you have a wizard who can only cast heal on human targets. He can query, is it a type gladiator human or type gladiator animal, right? We'll get to this from an inheritance perspective. In this case, we can say Jesse, instance of gladiator, true, right? Makes sense. Is Jesse instance of boolean? Negative. No, he's not. So instance of is another way utilized with prototype to identify that. Let's cover proto, that underscore proto. What is that guy and what does it have to do? We understand if prototype is really, you put things on it, all instances get it. Really, that's what it means. So what is this proto thing? So we'll get into inheritance in a minute. But again, proto really is just from an instance perspective. Hey, Jesse, who made you? Who is the class that made you? In this case, Gladiator. Gladiator.prototype specifically, okay? I know Chrome doesn't show it as that, but to be a little more specific, we can say Jesse Proto equals Gladiator.prototype and test that out, and it'll say true, okay? So the instance has an ability to identify who it is. This is important for prototype chains or inheritance. So let's do inheritance first, and then I'll show you the third way of doing class-based templates in JavaScript, okay? So, why inheritance? What is the point of inheritance? Well, inheritance is more dry. So, for example, in our Gladiator example, we have human gladiators and we have animal gladiators. They have a lot of things in common. They both have an attack, a defense, and hit point value, but the way in which they fight in battle is completely different. Yes, they share the same roll dice to get the same randomness, but the actual mechanics are differently. Bears have claws that are attached, whereas a human has many, many options. They have a shield and a sword, or maybe a dual, two-handed sword with no shield to add the defense. Very, very complex. So the behavior of a human and their attacking and defense is very, very different from how an animal particularly works. So we can share that same functionality in a base class, right? A base gladiator class to hold that functionality. And then each one of those subclasses that extends that class can handle that differently, right? So for example, it's more dry. It's a way to say, all right, instead of making two different classes, an animal class and a gladiator class, and they both do roll dice, they both have attack and defense and everything else, we combine them together, okay, into a gladiator. So it forms something called a prototype chain or inheritance tree. It's called a prototype train in JavaScript because that's how most people do inheritance. Some form of libraries like underscore and others will abstract that. If you open it up, it's really trying to make prototype manageable, right? That's what it's really trying to do and emulate base classes, okay? So there's no real way of calling super in JavaScript. There's no way to say call my super class. There's no, if you're from another language, there's no way to do function overloading. Right? You can do overriding very easily. You just overwrite the function on the prototype and call it a day. But there's no real easy way to differentiate between his prototype and mine and everything else. It becomes very strange, especially when you get more than two classes deep. So there is an inheritance tree, but it's not as straightforward. That's why the libraries exist in the first place. So again, inheritance is it inherits or extends. So my animal gladiator extends gladiator. My human gladiator extends gladiator. Most languages like Java and others have kind of created these terms such as abstract gladiator or base gladiator. It's known that those classes you're not supposed to instantiate. Those are just base templates, like the low underpinnings of how humans or gladiators are made. It's the actual real classes, the subclasses like gladiator, human, and gladiator animal that you're supposed to instantiate. Some classes can even enforce, some languages, can enforce that you can't do that. JavaScript, again, these classes are objects we can play with, right? So it's not really there. So let's show you some examples of inheritance here. So we have our gladiator class, for the most part, makes sense. Let's borrow some of the functionality. So we're going to get rid of that. We're going to get rid of our object, because obviously we can't do inheritance with objects. It's a single object. How are you going to inherit from another object? Or can you? You'll see it number 3. We're going to borrow some code that we had from the past. We're going to get a roll dice function, right? So every single gladiator will have the roll dice function. So say Jesse roll dice or roll. And you can see it's a function there. It's got it. He's got the same function everyone has. So if I modify it in one place, every single gladiator will use the same function. Cool. Again, our class or template or prototype method, they're all 3 synonymous. We're going to get our attack someone. In this case, something. It's not really a good function name. We should say attack target. Let's do that. Attack target. It's a little more appropriate. The target we're attacking. A lot better. Okay. We're going to get our apply damage function. We're going to get most of this stuff. Apply damage takes that particular person or the thing we hit. Because again, we're not dealing with people anymore. Could be animals as well. And okay, so we've got our gladiator. He's got all these wonderful functions to make dealing with fighting and battle very straightforward, okay? And again, a lot of this is from our previous video on objects and dealing with objects in general. In this case, test it out, everything's good. He's got all these methods. We'll look at the proto, see, or the gladiator's prototype that has all the methods that are defined. Apply damage, attack target, constructor function, which in this case is that big old thing up top right there. We have our get random target in arena and our roll function. Fantastic. We've got a great class template. Our factory function creates it like this. We can in fact replace it with this to make our code even more readable. Cool, same thing. We have our gladiator class, and that is our object template that we're going to make instances from. Let's make our first subclass that extends it. So first, we got to make some weapons, right, to identify a unique weapon object. So we're going to say a sword. Let's say weapon. And the roll that it takes to use it. How many die damage does it do? So we'll say how many die and type of die. How many die. So we have our very simple weapon class. It's just in this case a function. We can say new function, test it out. I'll save the file, refresh. So what's a weapon? Notice it's uppercase to define that it's a class. Again, we can use a normal object, but let's stick with the prototype, stick with the class-based way of doing things in JavaScript real quick before we start going down the rabbit hole of closures versus prototype versus object to create. Okay, so weapon is that. Sounds good. We can say sword equals new weapon. And again, we talked about this. You roll 1 10-sided dice. You have a 1 to 10 points of damage each time you roll it. Fantastic. We got our weapon. Sword is an instance of weapon, which is another way of saying sword is proto equals the weapon prototype. Learn how to spell. Sword equals weapon, not prototype. True. See why instance of is a lot more readable. Sword is an instance of a weapon class. You know, versus no, it's proto and it's helpful. This is why proto isn't even supported anymore. It's going away and blah, blah, blah. So, cool. We have our weapons. We can use them. We can make them. Fantastic. We're going to make a new class called human. And he has the exact same parameters as the gladiator. Okay, so we're going to actually, let's get rid of that instance variable. So let's copy that because we want the same thing. But the only difference is that a human defaults to no weapon. They have none. They don't start life with weapons. They have fists. Fists are not really helpful in a fight. That's not really the case. Any boxer knows that these are, you know, lethal weapons. Any martial artist knows these are lethal weapons. But for the sake of our case, we're going to assume that if you're attacking an armored foe or a bear, these are useless unless you're Bruce Lee. All right, so we have our human. Let's give our human the ability to extend or inherit from gladiator. How do we do that? There's a variety of ways to extend the prototype, and they all are awful. And they're very confusing because they don't all work exactly. Prototype was actually created to help traditional programmers understand the inheritance mechanism. It doesn't work because they're all kind of dependent on each other. So let's just take the classic way of saying, taking an existing prototype and saying, okay, that particular prototype or thing or object that it inherits from, before it was object, in this case, it's going to be a new gladiator, right? That particular object or that instance. Now notice new gladiator is a kind of blank instance, but we're saying, look, the gladiator instance is what your prototype points to, okay? So what does that mean exactly? Well, it means this. If we say Jesse equals new human, right, with the same standard attack, defense, and hit points, we have a human. It's a human object, right? But notice that its inheritance or base class for that particular one is gladiator, right? In this case, gladiator prototype. So he has all his internal properties, right? But his weapon's null, and he has the existing prototype properties stored on the past one. So these are his properties. It's just showing you the class template, which in turn gladiator, it has all his methods. So the prototype changed there. So we know that human is, and his proto equals the human prototype, right? Because he actually ported that. But what's interesting is that you'll notice that his constructor is not. So if you actually look at the Jesse.constructor, it actually is pointing to the Gladiator constructor. That's a little odd. Obviously, that's not true because we did Jesse new human. So why is constructor there? Well, you could choose to overwrite that if you wish, right? You could say constructor so when you do it again, you say, goodness gracious, Jesse. And then you say, all right, Jesse, what is your constructor? It actually points to the correct constructor. A minor thing, but again, this is kind of normal OOP stuff that just doesn't work out of the box unless this is why most people use libraries nowadays to abstract all this insanity. All right, so you get basic inheritance, right? A human extends, he gets all the same features. He just duplicates the constructor or overrides it, right? And has his own value, says, no, my default weapon is null, not sword or whatever else, okay? So the applied damage has to be modified slightly because we're dealing with, instead of roll 1d8, we're now dealing with weapon. So let's give each human a default weapon of, let's just say, every human's given, by default, they walk into their arena, a fork. Okay, so we'll say new weapon, which is a fork, and it's does 1d1 points of damage. So at most, if you hit, you can do 1 point of damage with stabbing somebody with a fork. All right, that's by default. The applied damage is going to have to take that into account. So instead of roll 1d8, it's going to get the weapons roll. In this case, this dot weapon dot how many die, this dot weapon type of die, right? So now, regardless of what the Gladiator has from a weapon perspective, it's going to use the weapon to determine the applied damage roll. Okay, cool. So they all get that inheritance. The difference is that humans default to a fork, and animals, let's make an animal right now. An animal, name, attack, defense, hit points. Copy the same internals. An animal will have some form of bite. So let's just say a bite automatically does 2 points of damage. Most animals have teeth. Most animals thrown into a gladiator pit are probably going to have some ferocious type of bite, which is a little more effective than stabbing somebody with a fork. Okay? So we can say 2 points of possible damage, anywhere from 1 to 2. Cool. So far we've got our inheritance tree. We're going to make our animal the same way. It's going to extend. Animal's going to extend gladiator. And its prototype is going to be the animal constructor. Okay, so far so good. Makes sense for the most part. We can make animals, we can make humans. Let's change these to humans. I'll make Carl, new animal. He's a bear. And his attack is, let's say 12. And I make it 14. He's pretty ferocious. His defense is 10. And his hit points are 14. So pretty strong. Carl's a big, nasty bear. However, his weapon, we're going to have to modify it here. His weapon, let's do this manually. Let's say his weapon is really nasty claws. So if he hits you, he's going to hit you with both claws, right? And possibly a bite. So we'll just make that 2d6. So anywhere from 2 to 12 points of damage. That's really nasty. Really nasty claws and a bite, okay? So that's Carl's weapon. So his specific weapon is going to do that. So when he gets in here, he has a higher chance of getting some really nasty applied damage. Now we have a bunch of subclasses. We have human and we have animals. The only difference for now, humans default to a fork and animals default to a bite, right? That's it. That's really the only difference between the two for now. All right, so let's start making some specific class things that allow us to override it, okay? So we're going to do some overriding here. Get random target in arena is an algorithm that defines how do we find somebody in this list or array of people in the arena. In this case, it's a random index, okay? So the animals, usually animals will find, if they're predators or carnivores, they're going to attack somebody who looks the weakest, right? It's a natural evolution of culling from the herd. They're going to find those that are the easiest to capture, whether they're injured or young or not very fast, okay? So we're going to modify this function. It's called overriding. So our subclass of animal is going to override how that works. And the way it does it is it has the same name, but it's on its prototype, animal prototype. So it's going to look for this first. Now this goes back to the prototype chain. Remember how I showed you the proto or prototype chain? This one, when we say, hey, get random target, it'll first look on the proto property for that animal instance. And if it doesn't find it, then walk its way up the chain to find it on gladiator. But it's going to find it on animal first because we're defining it there, overriding it, okay? So instead of getting an index in the arena, right? The arena is at the very top here. It's just an array of people that are in the actual arena, okay, or gladiators, animals, whatever. It's going to say, all right, here's the target array. Get a copy of it so we can play with it and modify it, okay? The items in the array are not copies. The array itself is a brand new thing we can play with. We can push, pop, modify, split, change the length, and it doesn't affect the original arena array, okay? That's all this concat does, gets a copy of it. Whatever my index is, like in that particular array, I'm going to take myself out of it, okay? So I got where I'm at in the array, and I take myself out because obviously I don't want to target myself, okay? I don't want to attack myself. So the crux of the algorithm is right here. Get a random person in the arena so I can attack them, right? And once I find that random index of that person in the array, and once it gets that random index, it returns that particular target. It says, here's the target that we found that you should attack, okay? So that is the crux of the algorithm. For animals, we want to modify this line right here. It's no longer get random. We are going to sort it by those who are hurt the most. So we're going to borrow the code we've already written down here. Before we called it a tiger. In this case, we want sort by lowest. So we're going to take out these. Sort by lowest is a sort function. So when you pass functions to an array sort, instead of doing a normal alphabetical and numerical sort, it'll actually utilize that sort function and run that function for every item in the array, depending on how it works, and each browser is different, and sort those arrays. In our case, we just say, look, if the hit points are higher than 1, we want it to the back. We want to get the lowest hit points to the front of the array. Once you've done that, you've sorted it, the first target is the one with the lowest hit points. Now, obviously, if everyone has 10, it's not going to really sort anything. It doesn't matter in that case, but you're going to attack somebody. You see 3 people, you're going to attack them. So that is how the animal targets a specific or particular person in the arena. Let's add them to the arena. Push, Jesse, John, and Carl. Sweet. So all 3 are in the arena. So Jesse has 10 hit points, and John has 12. So in theory, when we say, hey, Carl, can you get, real quick, I want to show you, animal. If you look at his proto, he has get random targets, it's targeted there, but if we go up 1 level, he has a different get target in arena, right? It's a completely different function versus the one that we've overridden, okay? So when we say, hey, Carl, get a random target in the arena array, it's going to get Jesse, because Jesse has lower hit points than John does. If we look at John, he's the second human in the array, right? John's hit points are 12, mine's 10. So we can call this 50 billion times, and it's always going to get Jesse. Now, watch this. We'll say Jesse hit points equal 32. He drank some potion of growth. He's now like 20 feet tall. He looks like really strong. When we call it again and say, hey, Carl, now who's the weakest? It's going to attack John, right? So that's how an animal thinks. It's going to attack the weakest, the simplest kill, self-preservation, right? That's how it's thinking from a carnivore perspective. Humans, complete opposite. I'm going to make every one of these type A personality people massive beefcakes, even me, right? That's right. And we're going to attack the strongest looking honking mofo in this particular arena. We're going to modify again our core algorithm here. We'll go up to human, and his is not going to be sort by lowest, it's going to sort by highest hit points. So we'll say return -1, return 1. I want the strongest person out of the arena that's who I'm going for. I don't care who he is. I'm going to attack him first. Once that threat is dealt with, I can deal with all these others who are not as strong. And again, we're using hit points as strength, which isn't really as accurate. Humans, being smarter, could probably calculate that somebody with a little more talent and a sword might not have as many hit points and look as tough and be as strong looking, but he's clearly more deadly, right? But for now, we're going to say, look, if you have more hit points, you're probably more of a threat, harder to kill. I'm going to go after you first, okay? So we'll then say sort by highest hit points for human, and then return that targeted array. So Carl, again, is always going to get Jesse by default because Jesse has 10. Now, there's one mistake that I want to show you, and this is indicative of a prototype language, or a language which allows you to define how the class is made at runtime, step by step in a procedural fashion. It's not like some template that's combined and then you can start instantiating instances off of it, right? The way prototype works is that you can actually affect things while it's running. So for example, Jesse get random target in Arena is not actually running his prototype function. If you look at the breakpoint here, we're running the Gladiator prototype random. Now your first question is, I thought we already went through this inheritance thing. How is that happening? It's happening because I don't actually I set the prototype to the Gladiator after I've set up the method on my prototype, right? So it's going to look on that particular proto first before it goes to the Gladiator's prototype methods. The prototype chain is backwards. So how do we fix that? Well, pretty simple. We corrected the chain, or order of operations. So as soon as we create our human constructor, we set up everything, inheritance, good to go. Then we define our override methods on it, okay? When we run it again, you can see that it's always going to return Carl every single time. It's using the new algorithm, okay? So again, it's setting the prototype first to who I extend from, then overriding your functions after everything's all set up, right? So you're modifying the prototype chain after it's been set. The prototype chain by default is object, right? Or who you extend from, right? Any class you make in JavaScript automatically extends from object unless you say, no, extend from Gladiator and make my constructor human, right? In this case, it's like, cool, got it. By the way, add an override method, make a unique get random target on my prototype, not theirs first. That is how we have humans target the stronger people and animals target the weaker people, okay? And again, we're just modifying that one particular method on each class, right? So they slightly differ in implementation, but everything else about a Gladiator is the same. They apply damage, get target area, attacker, the roll, right? All makes sense. And I mean, obviously they have unique ways of dealing with weapons that we set, at create time. Fine. Make sense? So that's a good example of why you would use inheritance. 90% of the functionality belongs in the base class, but there's some functionality that's unique to those particular types of classes, and we should put that in there. Now, some languages will make classes just for namesake. I want to know the difference between an animal object and a human, even if they have no unique functionality. And the reason for that is, as I showed you before, instance of. When you're debugging, you can see it's an animal in the browser, right? You can actually see that. You can see what its prototype chain is. You can say instance of to know that it is of type animal versus human. So some people will do that as well. You don't have to do inheritance just for that specific way, but that's just the basics, okay? So now that you understand the basics, let's talk about composition. And it's going to be really quick, I promise. You're going to love how quick it is. So composition means to compose. That means taking something and putting it inside of another thing, okay? So you're putting a thing or many things inside of it. In our case, we've already done it. We had a sword class or weapon class that we put inside of our gladiator class. That's composition. Now, you might say, well, why do you have composition versus inheritance? Well, as you can see from JavaScript, we haven't even begun to say super methods. How do I call my, get random target arena in the gladiator first? Like, what if I want to call that first to see what targets are there to get a random one, and then of those random targets, get the weakest of those two? You can do that, but you have to do some trickery to add certain things to prototype. It becomes very, very problematic. It's not like other languages say, just call super. JavaScript doesn't have that, unless you use libraries and everything else. So it gets to be really nasty. Let's talk about the last way of doing OOP without using a library, okay? And it's something magical called create. Now, it's not all supported in all browsers. There's a function that you can get online or a library that says you can use it in any browser, regardless of mobile, desktop, doesn't matter, and it'll work. They have a wrapper that says if it's not detected, go ahead and use the old version, okay? But we're gonna assume you're gonna be using the native functionality, okay? So instead of doing this insanity right here for human, we're going to do something called object.create. Humanoid prototype, object.create gladiator. Okay, makes sense? Notice we're doing it after our constructor function, but before our override method, same as before. So, a couple of awesome things have happened. Number one, a little more readable. Okay, you're going to create, now object.create has two parameters. We're not going to cover the second parameter tonight. It's a very deep subject. Object.create is an ECMA 5 script thing. It's only supported in modern browsers. There's a very wonderful, simple fallback function that you can guarantee will work in older browsers, so it's okay. I'll show that in the YouTube comments, okay? So, a couple things happen. Number one, Jesse, still the normal object. Its proto or base class still points to Gladiator, right? It still has all its unique properties. The prototype chain goes to its target and arena, back to the base class's target and arena, right? So it's all there. But here's a couple cool things. Again, Jesse still is an instance of human, right? But here's another thing. The Gladiator function, constructor function, doesn't get called, right? That's great, fantastic, wonderful. Okay, so all the normal stuff, a lot more readable. And look, even Jesse constructor points to the human constructor. Does it never end? Okay, so fantastic. Everything's good. Doesn't run a thing. The only thing missing is, again, based on normal inheritance, JavaScript. There's no real way to call super methods, right? So if you're, let's say you're abstracting all this stuff in your Gladiator, you don't want to call all this again, right? You just want to modify the weapon, obviously, but you don't want to call these functions again. Okay, you could say Gladiator dot apply this, and then name, attack, defense, hit points, right? So you can do that if you don't want to, but whatever. That's really the only downside. It's the same problem you'd have with using the prototype way. So object.create is ECMA 5. It's more efficient, superior way of doing inheritance and everything else. You can also say null to like not inherit from anything. The problem with that is that most libraries and people in Java expect toString and things like that to be around. So you really shouldn't do that unless you know what you're doing. So that is object create. It's a lot simpler and just a better, easier way of doing things. And as you can see, it has all the correct constructor, a more accurate proto or base class, right? Doesn't call the superclass constructor instance randomly, to cause some weird issues. Composition is going to be quick, I promise. So composition means to compose. It means to put something inside of something else. In this case, you're putting a thing or many things inside of it. We've already done this. We've taken a weapon class and put it inside the Gladiator. So rather than having a Gladiator extend from like something that determined its weapon type, we created a weapon class and put it inside of it. We said this dot weapon equals weapon VO, or the weapon class that we made, right? So that's the one thing you can do. Now, the reason composition versus inheritance comes up, especially in JavaScript, is as you've seen, it's very weird. There's no class, there's no extends, there's no super, like things that are offered in the majority of OOP-based languages. JavaScript's not an OOP-based language. It's a functional language that many people who are now using it are from an OOP background. This guy. So it's very confusing. And a lot of times composition is just as readable, more easily testable, and you don't get in this weird thing where your inheritance tree gets a little tricky. Like, do I add this in the base class and then bloat it? Or do I put it in a subclass and then I have a bunch of subclasses to manage? It gets very tricky. Composition, you don't have that problem. You just encapsulate the functionality in a specifically named class and inject it if you need it. It's that simple. So there's kind of a religious war about composition versus inheritance. Well, but again, we've already seen composition in action. So again, let's review. Again, the nomenclature, you understand OOP or object-oriented programming. It's just creating objects that have encapsulated functionality. You're using either an inheritance tree or a composition where you put in classes within classes, okay? It's for code organization. All your methods for that particular class go on that set of functions with those kind of properties. You're not putting properties on the prototype, just the methods. If you want to use objects to do that, you can do that as well. You don't have to use prototype. I've shown you the object option. And incidentally enough, you can use objects with object.create. So you can kind of emulate inheritance with objects, right? Again, no static though. Code scalability. Multiple people can work on multiple classes or multiple subclasses, right? And organize those things in a file. They don't have to be an all-in-one file like I showed you this evening. And encapsulation of the behavior. Each subclass, animal and human, had its own implementation. Same function name, same signature, same parameters, right? But different implementation. It's encapsulated behavior inside those functions. So the API of how you say, hey, pick a target, that doesn't change. But the internals, I can constantly change my heart's content. All right, folks, so one last thing I wanted to show you is the future of JavaScript development, right? The cool thing about JavaScript is that for the most part, it's a standards-based language. We refer to ECMA or ECMAScript or ECMA 5, ECMA 3 all the time. That's talking about the standard that JavaScript is based upon. Now, there are a variety of ECMAScript certified or based languages, ActionScript, JScript, a lot of other ones, right? But for the most part, future versions of JavaScript take a significant amount of times to get to any version of browser, and then multiple versions of browsers, and then having those browsers be updated on people's machines, mobile devices, whatever, okay? TypeScript's unique, just like any other transpiled language, is that you can code it right now, and the compiler will convert it to JavaScript for you, right? That's what's so great about it. So, for example, I can utilize TypeScript today to get all the wonderful ECMAScript, modules and class-based things, a normal OOP-based language with strong typing, right? We don't care about the strong typing, we just care about the OOP for now. And I can code it like a normal OOP language, and it handles all that. It handles all the super and everything else, right? So I wanted to make a clear delineation between something I said earlier about method overriding versus overloading versus overwriting, right? W-R-I-T-E. So we did method overriding, where you would have multiple methods on the prototype. Get, targets, right? It was on the human, and then get targets was on the gladiator. It's only really overriding if you borrow functionality. It's overriding if you basically smash that particular method. So we're going to do overloading, or we're going to do overriding here as well. But it's a little more clear because you have a super keyword. You can actually borrow functionality from the base class. So I'm going to make my humans roles more positive just because they're lucky or smarter for whatever reason, okay? So first we're gonna get our class weapon. Remember our weapon class? And you can see as I type the class, it's gonna generate a JavaScript class off to the right. Now you don't have to worry about these weird function things and all that. All you care about is the internals, right? In this case, function weapon, same normal thing. So when I say class weapon, we mean function weapon, right? So you can see how it's generating that JavaScript for us, okay? And we have a constructor function, right? A normal constructor function, which is the same thing in JavaScript for the most part. It's the function and the class are the same thing. In TypeScript, they're different, right? Because it's an ECMA 6 kind of base language. We can do this super awesome feature called public inside of the constructor, and it'll automatically generate the this for us. Pretty rad, right? So we're done. So that's our weapon. We'll get our gladiator class gladiator. And our constructor are going to use the same awesome public functionality for name, public attack, public defense, and public hit points. Right, as you can see, it's doing the same awesome thing there too. And we can say this.weapon equals null. So let's just say by default, Gladiator is a null weapon. So it sets it explicitly to null inside of JavaScript too. So the whole null versus undefined thing that CoffeeScript fixes and other data type issues, TypeScript doesn't handle that like CoffeeScript and others do, which is unfortunate. So I say this.weapon, but it doesn't say it actually exists. So let's go ahead and define it. We'll say weapon up top. So it actually has that property, okay? And you don't have to worry about this. We're just casting this weapon. You don't have to worry about that, but we're casting it as that particular type, okay? So again, it casts it to null. That's it. That's the end all be all JavaScript. Now, here's where it gets fun. We're gonna add our role function, which takes how many and what type to do, and it returns, a number, okay? So it rolls the dice. It automatically adds it on the prototype. Now you notice it's only for methods. It does not do this for properties, right? Now I can still have, if you remember, static, right? You have static. Remember that? Instances. I'm gonna call this number for now. And let's say defaults to 0. So you can see it does static the normal way you do static in JavaScript, the way I suggest, right? So that's cool too. It supports both. You got the static variables and everything else. Okay. So we've got our class function. That's pretty rad. It handles that. It has a wonderful, helpful way of writing constructors. Love that. Now watch this. We'll go class human extends gladiator. Isn't that awesome? And if you scroll down, we have our human class, and it extends human. It has its own extends function, which is a little more complex but simpler than object.create. It's unfortunate they don't use object.create, but they're basically saying, look, we have to have compatibility with other browsers, IE browsers, older browsers. So they're trying to be ECMAScript compatible with, at the same time, allowing the compiler to make sure it generates JavaScript that works everywhere, right? The whole point of TypeScript is to be ECMAScript compliant today, right now, and have strong typing and all the other OOP things that we love, but at the same time, generate JavaScript that anybody can use, right? It doesn't want to be exclusive, okay? So that's what it handles. All you care about is that you can get this nice little extends, which is awesome. Now, let's show you something interesting about the constructor. So we still have to call super in our constructor if we're going to define one. So we still have to go name and attack and defense. The whole public thing doesn't work in subclasses, unfortunately. But our weapon, we can override how it works in the base class. So by the time this function is run, our weapon is set to null by default. We're going to say new weapon 1 and 1, because humans start with fork, right, to poke. So you can have super. You can call super methods. You can call the super keyword inside of those methods called the base class methods. Super inside the constructor does that. For other methods that you override, right, how many, what type, we get our role, which is our super role, how many, and there's the code hints that's telling you what type. You can say our role equals role plus 1, and then return role. So we're human and we're lucky for whatever reason. So we can override its functionality by adding an additional 1 to the end result. So we always have a higher than normal role. We're humans, we're lucky, right? We're smart, whatever it is. So you have super, and it works. It works as normal. So if you go down here and look at the code it generated, it handles all the weird super underscore roll call with the properties and types and generation based on the fact that the super is a private property injected in your class, blah, 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 right? If you look at TypeScript, it's a normal OOP-based language, has OOP-based constructor functions, has super, has just about everything you could ever want from an OOP-based language. Pretty cool. The only thing really missing is the ability to import them and namespace them correctly in an easy fashion in multiple files. But again, for the most part, you can see we have our weapon, we have our gladiator class, the static, we have our constructor that automatically generates all that cool set stuff. We have an extends keyword as well as a class keyword, so we can pretty easily determine what class we're extending from. So pretty cool. That's where things are going. You can use this today if you'd like, but this is kind of where JavaScript's headed in the future. So it's not always going to be this functional language that's having OOP smashed on top of it. So that is object-oriented programming basics of doing inheritance, a little teensy bit of composition. So that's how it works. In a future video, we're going to talk about the prototype versus closure-based ways of doing things. We're going to talk about the scope of those classes and how you deal with that, and some of the ways you can deal with modules to asynchronously organize this huge chunk of code. So again, I hope that was helpful. My name is Jesse Warden. You got any questions, you can hit me up on email. You can follow me on Twitter, JesterXL. I'm on Google+. Don't forget to subscribe, and thank you very much for your time. I hope this was helpful.